Yes, very good morning, dear students. Welcome back to online physics class. So far we are discussing many concepts in this human and colorful world, and today, maximum I'm going to complete this chapter. I mean, human and colorful world. And I think last class already we discussed about atmospheric refraction and twinkling of stars and remaining some more concepts. So today I'm going to discuss important concepts that are the scattering, how light will be scattered, and about the Tyndall effect. Actually, Tyndall was a scientist, so how we can discuss Tyndall effect and different applications of scattering of light. I'm going to discuss today, dear students. Right? Already I told twinkling of a star is application of atmospheric refraction. It means twinkling of a star is due to the atmospheric refraction. And already discussed about how we define atmospheric refraction. Right? When sunlight passes through in the atmosphere, so that we call it is a when sunlight passes through atmosphere, then the refraction will be takes place. Why? Because it moves from one medium to another medium. So then this refraction we call it is a atmospheric refraction. And so here now I'm going to discuss about scattering of a light. So how scattered, the physical meaning of scattered means change its direction. Change its direction. How light will be scattered? See, dear students, when sunlight enters the atmosphere of Earth, then already we know in this atmosphere some atoms and different molecules, some different atoms will be there. Of course, different gases also will be there in the atmosphere. So whenever sunlight enters the atmosphere of Earth, then the atoms and molecules of different gases present in the atmosphere absorbs the light. So it receives the light so from the sun, right? So when what is that? When sunlight enters the when sunlight enters the atmosphere of Earth, the atoms and molecules of different gases present in the atmosphere absorbs the light, right or not? So then these atoms and molecules of gases re-emit light in all directions. Whenever these atoms and gases or molecules receives the light, so after that it re-emit the light. Of course, it will absorb some light and some amount of light. It will be re-emit the light in all directions. So this process is known as the scattering of light. Already I told initial itself, scattered, the physical meaning of scattered is the change its direction. Yes. And we know that light travels in the form of electromagnetic radiation. In light chapter itself, first itself I told electromagnetic radiation. It is a combination of electric fields and magnetic fields. So we know that light travels in the form of electromagnetic radiation. When these radiations interact with this matter means our surroundings. So whenever these radiations are interact with the matter, then scattering of light takes place. So of course, this phenomena is passed through colloidal solution. This phenomenon is passes through colloidal solution, then the path of the beam becomes visible. And one more, another important factor in scattering of light is relative size of the scatters. So scattering of light, we are almost comparing to the scatters, right? So scatters, it just I given the name is x. A small x is a here scatter. That is one of the name relative to the scattering, right? It is a relative to the scatter. Nothing just comparable. Just I given one name for scatters. It's x. So that x compared to the wavelength of light, this scatter, for example, I comparing to the wavelength of light. Now here two conditions will be there. That is, one is x less than is lambda. So then here scatter is very less than the wavelength. Then what happens means, see, when the size of scatter is much less than the wavelength of light, then Rayleigh scattering is valid. Here one scientist is there. Actually here we are not going that much deeply. In 12th class we can learn very thoroughly about this concept about scattering of light. Here one scientist is there, that is a Rayleigh. So he was defined some phenomena about scattering of light. That phenomena we call Rayleigh scattering of light. So when it is possible means scatter is a very less than the wavelength of light. Scattering of light or scatters is a very less than the wavelength of light, then his phenomena is valid. So that we call Rayleigh scattering. So however, when scatter is a very greater than the wavelength of light, that is a size of scatter is a much larger than the wavelength of light, then Rayleigh scattering is not valid. So these are the two conditions, right? So in that event, all wavelengths are scatters nearly equal. In that wavelength, whenever Rayleigh scattering is not valid, in that case all wavelengths of light are nearly equal. But all wavelengths of light, it should not be equal. Already I given wavelengths of different lights. So red have maximum wavelength and violet have minimum wavelength, and red have minimum frequency and violet have maximum frequency. So for that only, whenever this x is a very larger than the lambda, then Rayleigh scattering is not valid. It is not correct also. Why? Because we know all wavelengths of colors have different wavelengths is there for different colors, right? Yes. And these conclusions regarding the scattering of light have been verified experimentally by Tyndall also. So one more scientist said that only next one, that is a Tyndall effect. So these all conditions regarding the scattering of light already verified by experimentally by Tyndall effect. So it is a very very important concept, dear students, that is about scattering of light. Nothing is there. Whenever sunlight passes through the atmosphere, in the atmosphere different gases and atoms and molecules are absorbs the light, and these gases and these molecules and these atoms are re-emit the light, and this process is known as the, and this re-emit the light and changes the directions. This process is known as the scattering of light.